Welcome back. In our first episode, we stated that we had a new type of artificial intelligence that we are calling Gestalt AI. Gestalt is defined by Merriam-Webster's dictionary as something that is made up of many parts and yet is somehow more than or different than the combination of its parts. So, Jeff, how does this definition apply to the idea and the implementation of our Gestalt AI?
We start off with that process that I talked about in the first video, which is observe, measure, think, learn, and then come to an answer resolution. So let's take that apart kind of piece by piece and understand what's going on in each piece of it. The observe process, let's start off with the physics definition of the observe effect, which means if you observe something, you change it. So as we integrate ourselves into a website or into a piece of manufacturing systems or whatever we're using the AI to do, it's changing that environment. We accept that the changes occurred, and because we're observing the data the way we are, we're just accepting our existence in the environment as a natural component of that environment. During the observe effect, what we're doing is we're examining the data coming in and we're building expressions of mathematics as a kind of a predicate case of an input that drives the outcome downstream from that. So that first observe case isn't just collecting a data set and putting it in a table, but it's actually beginning to form the equations we use. The next part is the measurement system. During the measuring state, what happens is we've got data coming into a presentation and it's expanding, it's changing, it's moving around. That's changing the scale of things. So that scale in geometric terms might be Euclidean, but it doesn't have to be. It may be linear or nonlinear. All of these things can exist in how the data is presenting itself relative to other parts of it. The part of the Gestalt system that becomes very powerful here is we can find influence points in that data that isn't connected relationally. So there's no third term in the connection of A and B, right? It's not C is connecting A and B, but yet we can have the influence effects on these terms, algebraic terms, as they're being expressed inside this system. Then we get down to thinking. Thinking by itself is considering how all of the spatial expressions and the additive expressions of the system begin to form the state of where it's at that moment. So when we say that we do it in a moment, we take the live state of the data, not some model that's been cooked and baked and lost, but it's evolving real state, and we begin to apply that state to an answer that we want to get in that case. Now, alongside of that, separate and distinct from it, is our learning process. Our learning process looks at the information it sees and actually creates its own language that has not existed and is in fact local only to the domain of use. So let's take a domain everybody understands, an internet domain that they go to on a website. Let's say that's the boundary of the knowledge set. All of the language in that domain is specific to it. It's just like the example in episode 2 where we have our own symbolic encoder in our own head. We do that by domain knowledge expression of domain knowledge. This symbolic language is not decodable outside of there because it's unique to that domain. It's like speaking a dialect of archaic French that nobody speaks anymore. It's only true if you know what it means, and it's only true in the context where it's used. So we use those symbolic representations, this colloquial expression of the mathematics of symbolic expression, to solve the question of it understanding and beginning to get prepared to answer a question in a logical and constructive manner. Then when we do answer synthesis, what happens is we collide all these techniques and we put information that is in the proper rotation and in the proper scope to inform the language that's expressing what the answer is so that it knows that answer and knows the likelihood of the answer. This is how we create the response set in rapid response to the data that's being asked of us, and how our answer has good fidelity in that presentation of the information. That's a critical detail. In the original design coming out of the late 1990s in AI design, they were trying to solve the problem of informational truthfulness. It's basically called truth system solves. In our case, it's native to our architecture. It's not something we bolt on. We inherently know whether or not something is true or not. The AI teaches itself that and discovers it. So the final part of this, when it comes together, is when we put all these pieces together and they begin to work, what we get is a perfected result that's bigger than any of those pieces together, because they each cancel the errors and perfect the truth as they give the answers back, and they contextualize the possibilities and the probabilities all in one step. And that answer comes back as an answer that can answer a question with good fidelity and good context. So it's both on point, relevant, and effective.
So, Nick, you've described this AI as anticipatory as opposed to being manipulatory. Can you explain what that means?
Sure. So first, an anticipatory AI is really the crux of it is that it has an internal state model that attempts to reflect reality as it is right now, so that it can properly predict what's going to happen next, but it also adapts to the results of its predictions and whether or not they're true, what the next data coming in indicates, all this other stuff. So it's not in a fixed position. By contrast, a manipulatory AI is not trying to reorient its model to better reflect reality. It's trying to reorient reality to better reflect its model.
Mm-hmm.
Now, these aren't necessarily mutually exclusive, but there is a really important distinction here in the way of that we design the AI, because it fundamentally comes down to we designed the AI to be curious, but we didn't tell it how to be curious. Why not? Well, if we tell it how to be curious, that will reflect our perception of what we think curious means, what we think exploration means, all that other stuff, which is our personal bias. It makes it more likely that the model the AI learns will actually reflect us, not reality. Obviously, we're a part of reality, but we're a limited part, and the AI is supposed to work on not just me. Beyond that, the goal when the AI is interacting with an actor isn't to convince them to do something or to convince them that doing something is in their best interests, whether it actually is or isn't. The goal is to anticipate the path which maximizes the likelihood of that actor fulfilling the objective function. Now, that path might not exist. There might be a user that is never going to get to, for instance, in e-commerce, a sale for whatever reason. Then that's totally fine. A failure of the model to encourage that objective is another data point it can learn from. But if it can't find a path, it will try to find a new one. That's part of that curiosity. It'll say, well, I have no idea of all the paths I've seen so far, that none of them look like they're going to get you to success. So let's try something new, see if we can get there. And like I said, if it doesn't work, well, it doesn't work. That's another data point. And if it does work, that's a new successful pathway that it can now extend to other users similar to that one. Now, with respect to manipulation, a lot of the manipulation, or rather the manipulatory aspects of AI, actually come from the way AI is framed and how it interacts with people rather than the AI itself. So without naming any names or giving specific examples, if you build a website in such a way that the interaction points with an AI are designed to promote addictive behavior or negative reactions or emotional dependencies, all that other stuff, then you have now injected externally a manipulatory aspect that wasn't native to the AI. But this is another form of bias that actually influences the way the AI learns, because that's the data it's being exposed to. If you put it in situations where it's supposed to manipulate people, that's what it will learn. Now, obviously, all data contains some bias. Unless you literally knew everything, you can't build a data set with no bias. But for us as designers and implementers, it's important to avoid injecting more. Why? Well, because the broader goal is to have the AI reflect reality, to maximize the fidelity of what it knows, the truthfulness, as Jeff alluded to, and therefore to make its answers as close to reality as possible. This is a constructive effect that happens because both the Gestalt AI and the anticipatory nature of how it explores and learns work together in that way. They're both trying to find that high fidelity representation. The Gestalt AI perfects relational, or not relational, I apologize, relationship fidelity. Which things influence what? They don't actually have to be relational, as Jeff said. There doesn't need to be a direct connection, but there's some form of influence between them. The anticipatory aspect is looking at the context and figuring out, okay, I'm here, I've been there, this is influencing me, this is influencing me. Where am I going to go next? But it's not trying to change reality to reflect it. It's not trying to influence reality in that way. It's trying to make itself reflect reality.
Continue to follow our series where next episode, we're going to talk about the cold start capabilities of this AI.